In today's lesson, we're going to talk about solving equations. First, we're going to talk about what it means for something to be a solution to an equation. Then, we'll talk about three different types of equations: a conditional equation, a contradiction, and an identity. Then, we'll practice solving different types of equations, like the equations you see here. To start, we're going to review how to determine if a number is a solution to an equation. Let's start with problem number 1. We want to determine if x equals -1 is a solution to the equation shown here. If a number is a solution to your equation, that means when you plug that number in for x, it makes this side of the equation equal to this side of the equation. So let's check. So wherever I see x in our equation, I've plugged in -1. Let's go ahead and compute the left and the right side of our equation. -1 minus 3 will give us a -4, so we're left with -3 times -4. Over here, let's see, this will leave us with a +4 plus 3, and -5 times -1 will give us a +5. Okay, let's see, on the left, -3 times -4 will give us a +12, and on the right, 4 plus 3 plus 5 will give us 12. So we took the value -1 and plugged it in for x into our equation, and that made both sides of the equation equal. Both sides of the equation are 12. That means that x equals -1 is a solution because it made the left side equal to the right side. Let's quickly see an example of what happens if you have a value that is not a solution. For problem number 2, we want to determine if t equals -15 is a solution to the equation shown here. So to determine if it's a solution, we want to plug in -15 for t and see if that makes the left side of the equation equal to the right side of the equation. Okay, so I plugged in -15 for t. Now let's simplify the left side of the equation and the right side of the equation. I'm going to write this as -15 over 1. And when we're multiplying fractions, we just multiply the numerators and the denominators. So 4 times -15 will give us -60. 5 times 1 will give us 5. Minus 8. And then over here, I'm going to work inside these parentheses. -15 plus 1 will give us a -14. -60 divided by 5 gives us -12. 3 times -14 gives us -42. Now, -20 does not equal -21. So when you plug in -15 for t, it does not make the left side equal to the right side. So that means that t equals -15 is not a solution. Now we just practiced how we will check our work when we're solving equations. When we're solving equations, we'll get an answer like this: x equals -1. To check to see if x equals -1 is the correct solution, you just plug it into your equation for x and make sure it makes the left side of the equation equal to the right side of the equation. If it does, you'll know you've found the correct solution. Next, I'd like to review the three different types of equations that we'll see. The first type of equation is the most common type of equation that students see. It's called a conditional equation. A conditional equation is an equation that has at least one solution, but it is not satisfied by every real number. Now, conditional equations are usually the first type of equation that students learn when they're studying equations. When you're solving a conditional equation, you'll get an answer of the form x equals some number, such as x equals 7, or x equals 0, or x equals -2/3. These are just some examples, but again, when you're solving a conditional equation, your answer will be of the form x equals some number. When you have a conditional equation, the way that we typically write our answer, let's say you solve the equation and you get x equals 7. To write your final answer, you can simply write x equals 7, or you can write your answer using solution set notation, which looks like this. And we'll see examples of conditional equations shortly. The next type of equation is called a contradiction. A contradiction is an equation that has no solution. When you solve an equation that is a contradiction, you will end up with a false statement, such as 5 equals 2, for example. You'll end up with something that does not make sense. 5 does not equal 2. This doesn't make sense. Or you might end up with something like 0 equals negative 10. And we'll see an example of this shortly. There are different ways to write our final solution for equations that are contradictions. You can simply write no solution, or you can write this symbol, which means no solution, or you can draw empty brackets, which also means no solution, or you can write the words empty set. The last type of equation that you'll see is called an identity. An identity is an equation that is always true, regardless of what values are substituted in for the variable. When you solve an equation that's an identity, you will end up with a true statement, such as 0 equals 0, or you could end up with something like negative 5 equals negative 5, or you could end up with something like 7x plus 1 equals 7x plus 1. The important thing is that when you're solving an equation that's an identity, at some point during the process of solving the equations, you will end up with both sides of the equation being identical. When you have an equation that's an identity, what that means is that the solution is every single real number. You could plug any number into your equation, and any number will make the left side of the equation equal to the right side of the equation. There are different ways to write our final solution. For the final solution, you could write all real numbers. We can also write our final answer using set builder notation, and that would look like this. And we would read this as the solution is the set of all x, such that x is any real number. Now that we've reviewed the three types of equations that we'll see, conditional, contradiction, and identity, next we'll get practice solving these three types of equations. Now we're going to be solving linear equations. Linear equations will have x, but they won't have x's with any exponents on them. They won't have x squares or x cubes or x to the fourth, for example. They'll just have x. Here are the steps that we can follow when solving any linear equation. The first step when you're solving any linear equation is if there are fractions, we're going to get rid of the fractions. This problem here does not have fractions, so we can skip step number 1. As we move on to step number 2, we're going to distribute. So let's see, on the left side, we could distribute the negative 2. So let's start by just bringing down the 5x and the plus 3. Then if we take negative 2 times x, that'll give us negative 2x. And negative 2 times negative 1 will give us a positive 2. So we've distributed on the left side. Now let's also distribute on the right side. On the right side, we can distribute the 2 to the 7x and to the positive 1. We'll bring down the negative 5x, and 2 times 7x will give us a positive 14x. 2 times 1 will give us a positive 2, and then we'll bring down our 5. After we've distributed, step 3, we want to combine like terms. For step number 3, we're still working on the left side independently and on the right side independently. Let's look at the left side and combine any like terms on the left side. 5x minus 2x gives us 3x, and 3 plus 2 will give us a positive 5. Now let's combine any like terms on the right side. Negative 5x plus 14x will give us a positive 9x. And then 2 plus 5 will give us a positive 7. In step 2 and 3, we're simplifying the left side separately and we're simplifying the right side separately. The goal of solving an equation is to isolate x. You want to get x all by itself on one side of the equation, and you want to end up with x equals some number. In order to isolate x, in step 4, we're going to add or subtract to get the variable on one side, and the constant, or the numbers, on the other side. So let's suppose we want to get x on the left. Let's go ahead and subtract this 9x from the right side. And then if we subtract 9x from the right side, we have to also subtract 9x from the left side to keep the equation balanced. Let's see, 3x minus 9x will give us a negative 6x. Bring down the plus 5. These cancel. So we've gotten rid of the x on the right side of the equation, and we can just bring down the 7. Now in step number 4, we're adding or subtracting to get the variable on one side of the equal sign and the constant on the other side. Let's subtract 5 from both sides of the equation, so we have the x on the left and the constant on the right. And we're left with negative 6x is equal to 2. Now we've completed step 4. We've added or subtracted to get the variable on one side and the constant on the other side. Step number 5, the last step, is you're going to multiply or divide in order to isolate your variable. Right now, to isolate x, we have to get rid of this -6. X is being multiplied by -6. So to get rid of the -6, we have to do the opposite of multiplication, which is division. So let's divide this side by -6. And if we divide the left side by -6, we have to divide the right side by -6. -6's cancel, and we're left with x on the left is equal to 2 divided by -6, and we can reduce 2 divided by -6 to -1/3. Notice we had a negative in the denominator. In mathematics, we typically don't like to write our final answer with a negative in the denominator. We either move the negative to the numerator like I did, or you could also put the negative out front. So we end up with our final answer, x is equal to -1/3. You can use a calculator to quickly check your work here. Plug in -1/3 for x here and calculate this. You'll get some value. Then plug in -1/3 for x on the right side and you should get the exact same value. To write our final solution, we can either write x is equal to -1/3 like this, or we can write our answer using solution set notation, which would look like this. Now, is this equation a conditional equation, an identity, or a contradiction? Let's look back at our notes. We said that if you get a normal answer, x is equal to some number, like 7 or -8 or 0 or -2/3, we call that a conditional equation. So we got an answer, x is equal to some number. So this is a conditional equation. Why do we call it a conditional equation? We call this a conditional equation because this equation is true. The left side will equal the right side under one condition, and that one condition is when x is equal to -1/3. Now let's take a look at an example of an equation where we have fractions. Now when you have equations involving fractions, there are more than one correct way to solve it. But I'm going to show you one approach for solving equations involving fractions. Many of us don't like dealing with fractions, so this approach is nice because it eliminates the fractions so we don't have to deal with them. Let's look back at our steps here. Step number 1 for solving a linear equation is to get rid of any fractions. And we're going to get rid of fractions by multiplying every term of the equation by the LCD over 1. So for the first step, we have to actually figure out what is the LCD. When you're looking for the LCD, you want to ask yourself, what is the smallest number that all of your denominators multiply into? That would be 6. 6 is the smallest number that all of your denominators multiply into. Now, whenever you have an equation involving fractions, you can always get rid of your fractions by multiplying each and every term by the LCD. So I just went ahead and took this term and multiplied it by the LCD over 1. And then I've taken this term and multiplied it by the LCD over 1, and then I've taken this term and multiplied it by the LCD over 1. Once we actually compute this, you'll see that our fractions will disappear. Now, when we're multiplying fractions, we just multiply the numerators and multiply the denominators. So let's see, 6 times 3x will give us 18x, 1 times 2 will give us 2, 6 times x will give us 6x, 1 times 6 will give us 6, and then over here, this will give us -30 over 3. Let's see, 18x divided by 2 gives us 9x. 6 divided by 6 gives us 1, so we're left with 1x, or just x. And then -30 divided by 3 gives us -10. Anytime you have an equation involving fractions, if you multiply each term by the LCD over 1, your fractions will completely disappear. Now we've just got a basic linear equation that we can solve. Let's see, when we're solving linear equations, first, get rid of fractions. We did that. Step 2, distribute. Well, there's nothing that can be distributed, so we can skip step 2. Step number 3, if there's any like terms on the left side, we'll combine them, and if there's any like terms on the right side, we'll combine them. I see 2 like terms here. 9x plus 1x gives us 10x. And nothing can be simplified on the right side, so we'll just bring down the -10. For step number 4, we want to get the variable on one side of the equal sign and the constant on the other side of the equal sign. This is already the case here, so we can skip step number 4 and move on to step number 5. The goal of step number 5 is to isolate the variable. This x is almost isolated, we just need to get rid of the coefficient, the 10. So since x is being multiplied by 10, the opposite of multiplying by 10 is dividing by 10. So let's divide this side by 10, and then whatever you do to one side, you have to do to the other side. So these 10s cancel, and we're left with x is equal to negative 1. So our final answer here is x is equal to negative 1. Now I'm going to very quickly show you another approach for solving this problem. I'm going to start by copying down this same first step where we multiplied each term by the LCD over 1. Now, instead of multiplying the numerators together and multiplying the denominators together like we did here, and then simplifying this step to get here, we can actually jump right from this step to this step by doing some canceling. We can take 6 divided by 2 to get 3. And then we can multiply the 3 times the 3x to give us 9x. And all that we're left with in the denominator is 1. If all that you're left with in your denominator is 1, you don't have to write it. Over here, we can take the 6 and divide it by 6 to get 1, and that leaves us with a positive 1x in the numerator, or in other words, plus x. And in the denominator, we're just left with 1, so we don't have to write that. Then over here, we can do some canceling. We can take 6 divided by 3 to get 2. And then we'll take 2 times negative 5 to give us negative 10. And in the denominator, again, we're just left with 1, so we don't have to write it. So we see that by doing this canceling, we still ended up with the same answer we did over here, but we just skipped this intermediary step. So we would continue solving this exactly as we solved it over here. Both approaches will work. You can pick whichever approach you prefer. Now for our final answer, we can write our answer like this, or we can write our answer like this. Now, what type of equation is this? Is this conditional? Is this an identity, or is this a contradiction? Since we got just a normal answer, x is equal to a number, this is conditional. Next, we're going to see an example of an equation that's an identity and one that's a contradiction. So whenever we're solving an equation, we can follow those same steps. First step, get rid of any fractions. And we get rid of fractions by multiplying each term by the LCD over 1. So first we have to ask ourselves, what is the LCD? To find the least common denominator, you're asking yourself, what's the smallest number that all of the denominators multiply into? Well, what are the denominators here? Well, we have 3 is this denominator. Over here, the denominator is an implied 1. Here the denominator is 3, and again here the denominator is an implied 1. So the least common denominator is going to be the smallest number that 3, 1, 3, and 1 all multiply into. That would be 3. So let's go ahead and multiply each of these terms by the LCD over 1. So I've multiplied the 2x over 3 times the LCD over 1. Then I've multiplied this term by the LCD over 1. Then I've multiplied the 20x over 3 times the LCD over 1. And then I've multiplied negative 6 by the LCD over 1. Now, you could just multiply the numerators together and the denominators together and simplify from there, or you could use the canceling approach. I'm going to use the canceling approach since it's a little bit quicker. So here, we can cancel the 3's, and that will leave us with 2x over 1, or 2x. Now, how do we deal with something like this? Remember, when you're multiplying, the order of operations tell us to multiply from left to right, so I'm going to do just that. I'm going to multiply from left to right and first take 3 times 6 to get a positive 18. And then we can multiply the 18 times the x minus 1. And I'll do that by distributing in just a minute. Okay, let's go ahead and cancel the 3's here. And that will leave us with 20x over 1, or 20x. And then this is just negative 3 times 6, which will give us negative 18. Notice we multiplied each term by the LCD over 1, and that got rid of our fractions. Multiplying by the LCD over 1 always gets rid of your fractions. And why are we allowed to take this equation and multiply everything by the LCD over 1? Because remember, with equations, as long as what you do to one side, you also do to the other side, your equation will be balanced. So we multiplied each term on the left side by 3 and each term on the right side by 3, so our equation is still balanced. Once we've gotten rid of our fractions, step number 2 says to distribute. So let's go ahead and distribute the 18 here. This will leave us with 2x plus 18x minus 18, 20x minus 18. Step number 3, we combine any like terms on the left side and we combine any like terms on the right side. On the left side, we can combine the 2x plus 18x to give us 20x. Bring down the minus 18. And on the right side, there are no like terms, so we'll just bring down the 20x minus 18. Now we can actually stop here. And let's look back at our notes from the first page for a minute. When you're solving an equation, if you end up with both sides of the equation being identical, we call that an identity, and that means the solution is all real numbers. So as soon as you notice that both sides of your equation are identical, you can stop. So you can stop here. But out of curiosity, let's see what would happen if we tried to continue solving this. The next step is we want to get the x on one side of the equation. Right now, x appears on two different sides of the equation. So let's suppose we want the x to appear only on the left side. Let's subtract 20x from the right side, and then we'll also subtract 20x from the left side. Well, these will cancel and leave us with negative 18. And these will cancel to leave us with negative 18 on the right. Now there are multiple different ways to solve this equation. You might solve it differently and you might end up with 0 equals 0, or you could solve it and end up with 20x equals 20x. And there are other solutions you could end up with. So your final answer might look different, but no matter how you solve this problem, you will always reach a point where the left side is identical to the right side. We call this a true statement. And when you end up with a true statement where the left side is identical to the right side, the solution is all real numbers. What does that mean? That means that you could plug any value for x, any number that you can possibly imagine, and no matter what number you plug in for x, the left side will always equal the right side. In fact, every single real number plugged in for x makes the left side equal to the right side. And we could write our final answer like this. Another possible way to write our final answer is using this set builder notation. And when you have an equation with the solution all real numbers, we call that type of equation an identity. Okay, let's take a look at one last example together. Now, if we're following our steps, the first step is to get rid of the fractions by multiplying each term by the LCD over 1. So first we have to determine what is the LCD. So what is the smallest number that all of the denominators 4, 3, and 2 multiply into? That would be 12. Now, to get rid of our fractions, we're going to multiply each term by the LCD over 1. So first I multiplied this term by the LCD over 1. Next, I multiplied this term by the LCD over 1. And last, I multiplied this term by the LCD over 1. Now, before we proceed, when you're multiplying each term by the LCD over 1, if you notice any of your fractions have more than one piece in the numerator, I'm going to recommend you add parentheses around that numerator. So here we have two terms or two pieces in the numerator, so I'm going to add parentheses. Here we have two terms or two pieces in the numerator, so I'm going to add parentheses. Here there's only one term in the numerator, so we don't need to add parentheses. Now there are a couple different ways to proceed from here. You might be tempted to distribute, and you can. You could end up with the correct answer by doing that. But I'm going to recommend before you distribute, let's completely eliminate all of the fractions. So one approach to eliminate the fractions is we could use that canceling approach. So I notice here we can take 12 divided by 4 to get 3. And that will leave us with 3 times 2x plus 3 in the numerator. And we're just left with 1 in the denominator, so we don't need to write it. Let's do some more canceling. We can cancel the 12 divided by 3 to give us 4. And then we'll be left with a positive 4 times the quantity 3x minus 1. And we'll only be left with 1 in the denominator, so we don't need to write it. Finally, over here, let's cancel the 12 divided by 2 to leave us with 6. And then 6 times 3x will give us 18x. And again, we're left with 1 in the denominator, so we don't need to write it. We see that by multiplying each and every term by the LCD over 1, and then doing some canceling, we quickly got rid of all of our fractions. Once you've gotten rid of your fractions, step number 2 tells us to distribute. If we distribute the 3 to the 2x and the 3, that will leave us with 6x plus 9. And then if we distribute the 4 to the 3x and the minus 1, that will leave us with a positive 12x minus 4, and then we can just bring down the 18x. Once we've distributed, step number 3 is to combine any like terms on the left side, and if there are any like terms on the right side, combine those as well. On the left side here, we can combine 6x plus 12x to give us 18x, and 9 minus 4 will give us a positive 5. And on the right side, there are no like terms, so we'll just bring down the 18x. Now, we've simplified the left side as much as possible, and the right side is as simplified as possible. The next step is we want x to appear on only one side of the equal sign. Right now, x appears on two different sides of the equal sign. So first, we're going to add or subtract in order to get x to appear on only one side of the equal sign. Let's say we want x to be on the left side. Well, then we need to subtract away this x on the right side. So let's subtract 18x from the right, and then we have to subtract 18x from the left. Well, something interesting happens here. 18x minus 18x gives us 0. Those cancel out, so we're just left with 5 on the left. And again, 18x minus 18x gives us 0, so we're left with 0 on the right. So we're left with the false statement, 5 equals 0. This is simply not true. 5 does not equal 0. Now notice, depending on how you solve this problem, you might end up with a different but correct false statement. You might end up with 0 equals negative 5, for example. Even if you end up with a different false statement, the important thing is that if you solve this problem correctly, you will always end up with a false statement. And when you are solving an equation, if you end up with a false statement, that means there is no solution, which means there is no real number in the universe that you could plug in for x that would make the left side of this equation equal to the right side of this equation. It's impossible. When the solution is no solution, there are many different ways to write your answer. You could write no solution, or here are some other correct ways to write your final answer. When you have an equation with no solution, we call that type of equation a contradiction. So we've now seen examples of the 3 different types of equations. If you solve an equation and you get the answer x equals some number, like x equals negative 1/3 or x equals negative 1, that is a conditional equation. If you solve an equation and you get a true statement, both sides of the equal sign look identical, that means the solution is all real numbers, and we call that type of equation an identity. If, on the other hand, you solve an equation and you get a false statement, the solution to that equation is no solution, and we call that type of equation a contradiction.